In this video, I will show you how to use an app in your phone called Spyglass or Commander Compass Go to search for your rocket when it is not equipped with the tracker. Both apps are available for iPhone and Android devices. Spyglass is affordable at $5.99. Commander Compass Go is from the same developer and it's free, but it has a few less features and includes pop-up reminders to purchase or subscribe. Just search for it in the App Store. It's easy to find. Of course, you may find other apps which work equally as well with my approach. The search for this rocket is what prompted me to find a better way of determining where to search for my rockets. On this launch, the rocket reached an altitude of 1,300 feet and landed only 600 feet from the launch pad in a field of tall grass and brush. It still took me 20 to 30 minutes of searching to find it, because I was focusing my search efforts in an area 1 to 200 feet south of where it landed. Can you see the parachute in the tall grass? This method will help you search for and more quickly find your rocket when it lands in wooded areas, tall grass, valleys, farm fields, or other situations where you don't have a direct line of sight to your rocket on the ground. Had I used the method I'm about to show you, it would have significantly reduced my search time when looking for this rocket. So in this video, I assume you have a basic knowledge of how to use the Spyglass app. The developer of the app has posted several instructional videos and documents. I would encourage you to check them out. After opening the app, the first thing you need to do is save the current location you are observing from. This is where you are standing when you see the rocket land. I'll call it your starting location. This is important as it is your first point of reference for determining your course. Tap the screen once to call up the first menu, then tap on the small flag icon. Click on Add Current Location. Name the location and select Done. In my case, I was standing at the LCO table when I observed my launch. That was my current location at the time. As I watched my rocket descend, I prepared to establish the bearing it landed on. To do so, make sure the back of your phone is facing squarely in the direction which the rocket landed. The red arrow indicates where I last saw the rocket before I lost it in the tall grass or trees. Make sure your phone stays facing the correct bearing and tap the screen once to call up the first menu. Tap on the small flag icon, then select Add Current Bearing. If you think you've moved your phone in the process, start this part over. If you don't, you will have saved the wrong bearing. Name the current bearing and select Done. I usually use the rocket name, so there's no confusion. Now we are going to make sure our pointers are only pointing us toward the two locations we intend them to, the current bearing and the current location. I'll refer to your current location as your starting location. Click on Manage Destinations. Make sure your current bearing for your rocket is set as pictured and is your primary target. Make sure your current or starting location is being tracked as well. It should not be your primary target. At first, your current location pointer may behave erratically. That's because you are too close to your current or starting location setting. Once you get some distance from it, it will point more accurately. Now, start your course by walking in the direction your current bearing pointer is indicating, while keeping your starting location pointer in line with the bearing pointer. Remember, finding your rocket is about staying on course, not just staying on your bearing. In this example, my starting location pointer is drifting to the right, which means I'm starting to walk to the left of my course, and I need to start making some progress to the right to get back on course. I do so until my starting location pointer and my current bearing are lined up again. I added the green and purple lines for reference. When the two pointers are lined up, then I know I'm on the right course. Don't worry about having the two arrows lined up perfectly. You'll be chasing the arrows with every step if you try to do that. And one reason this method is so helpful is because you can walk far out of your way to go around large obstacles, then get right back on course with the two pointers lined up again. Once you do that, just resume walking towards your rocket's bearing. Here's the thing. If you navigate only by taking a compass bearing or by line of sight observation with a tree or other object, that can significantly change your search area if you get off course. All right, let's get started. In this example, the red binoculars represent my starting location at the LCO table. It's where I was when I observed the rocket land. The white arrow represents a southwest bearing of 225 degrees from my starting location to where the rocket landed. The solid red lines indicate an approximately 50 to 100 feet wide corridor, which I can see and search in from my straight line course, narrowing down my search area considerably. The black dotted line represents a drainage ditch or other obstacle, which I cannot cross and must go around. The lower compass symbol shows where I am at when I have gotten around the ditch. Now, if I start back on my bearing of 225 degrees from there, I will be pointed in the right direction, but I will be off course by several hundred feet, and I will be searching the wrong area of the woods. Instead, after I clear the ditch or obstruction, I will head west or slightly northwest to get back on course. If I get those compass pointers we talked about earlier lined up before I reach the woods, then it doesn't matter how deep into my course that rocket is. If I stay on course and I stay in that corridor, I will eventually come upon my rocket without having to complete a time-consuming search pattern through the woods or tall brush. Oh, and I do realize the spyglass screen map and the launch field map are different locations. That's okay. For our purposes, it doesn't matter. I just got better examples and it was more convenient to do it that way. Well, I hope this tutorial helps you when searching for your rocket. Please let me know in the comments if you have any questions about searching using this method.